Hey, this is OXDF, and today we're looking at Advent of Code 2022, Day 9, Rope Bridge. Um, the description here is a bit long, but I'm going to try to summarize it for y'all. My input is going to look like this. I'm going to have a direction and a number of steps, so right 4, up 4, left 3, etc. I'm working with a rope that follows me. So basically what's going to happen is both the head and the tail are going to start in some state. We'll call this 0, 0. So then we're going to move right 4. And so what happens is the rope moves a step to the right, or the head, and then the tail, because it's within one block, it's there. Then the rope moves to the right again, because we're moving 4. And this time the tail would be here, but the tail can't, if the tail gets more than within the surrounding points, including diagonals, it's okay, then it moves to catch up. So in this case, it's here, it moves to catch up here. So then again, we take a step to the right, the tail moves to the right. Take a step to the right, the tail moves to the right. Now, when we move up 4, so we move up here, the tail doesn't move because it's still within the surrounding 9 block, the block of 9 around our current spot. But then when we move up, the tail was here, it actually jumps to the diagonal. And so basically what happens is if the tail is in the same row or in the same column as the head, it moves one, and it's more than a space away, it moves a space towards it. If it's not in the same row or column, it moves in both directions towards the head. And that is our puzzle. Oh, and then the last trick at the bottom, we have to track everywhere the tail goes and record the number of positions the tail visited at least once. All right, so let us see. We come here and we use our Genday script for day 9. Is that right? Yeah. And we will come over here and check it out. Our input, just real quick, is a lot longer. We got 2,000 moves. Again, 2,000 rows. So we're gonna come up here and let's get started. We will start by doing a for line in lines and looping over our lines for sure. We're gonna need to track. We could go into like making classes for this stuff, but I think for now this is simple enough. We can do it without. We're gonna need to track like hx, hy, tx, ty, and they'll all start at 0. Ooh, that's ugly. All right, like that. And so now we're going to need, well, I guess we'll start by moving the head. And so what we're going to do is in the line we're going to get a direction and a num. That's going to be equal to line.split, like that. So now we can say for underscore, because we don't actually need the number, in range int num. So that's how many, we're going to take how many steps, and we're going to, actually, let's move this here. This is where we're actually going to move the head. For the head, we'll say hx, hy equals, and now we need to get, I guess we need to get the move m equals, let's come up here and define ourselves like a little like move equals, and we're going to make ourselves a dictionary. So like if we have a left, left will be -1, 0. Right will be 1, 0. Don't need this. I don't know why I got 2 sets of parentheses. Up will be, in this, it doesn't matter as long as we're consistent. So we'll say 0, 0 is the top left. So up will be 0, -1. And down will be 0, 0, 1. Okay, so now that we have that, we can say m equals move of, move of direct. Typing is hard today. Direction. That, and now we can say hx plus m0 and hy plus m1. All right, so now we've effectively moved our head where we need to go, right? So we get the direction Here, that many times we're going to get, in fact, we could actually move this only get done once. Put that here. Oh. Right, like that, and like that. Okay, so now we parse the line, we get the move, and then that however many times we're gonna then make that step. So that's pretty good. Now we need to update the tail. The tail's gonna be more complicated, clearly. So let's first we'll say like dx dy to be like a delta difference between them will be hx minus tx hy minus ty. For what it's worth, I could be doing these as like h being like a tuple or a vector, and I'm just deciding that like instead of having to type, if that was the case, I would say like d equals h sub 0 minus t sub 0, comma h sub 1 minus t sub 1. And really, I'm making the design decision here that because I'm assuming I'm operating in two-dimensional space, and I'm not going to be assuming that part 2 is not going to be like, okay, now these each have 8 dimensions or even 3 dimensions. Like, it's just easier just to not have to type all these brackets all the time. So I'm just kind of having 2 different variables rather than a single variable with multiple parts. You go either way on that. All right, so now we've got our delta. So we need to do if either one of the things is greater than 1. If either delta is greater than 1, we're gonna have to move, right? So we'll say if abs, I don't know why I put that, abs dx greater than 1 or abs y greater than 1, we're gonna move tail. How do we move the tail? We're gonna say if dx, so if there's some difference in the x coordinate, we will say tx plus equals, and this is a tricky one. What I need to do is move one space in the direction of dx. So I'm actually going to do math. Let me import the math library. There's no sign function, which is annoying in Python. I think. Double check that. I'm pretty sure math.sign is not a thing. Yeah, I mean sine and cosine, but there's a thing called copy sign, like that. And so we basically going to say we want the number 1 with the sign of dx. And that's what copy sign does. So this will take the sign of dx and multiply it and put that on the number 1. And then we're going to add that to tx, and that'll be our change. And then we can say if y, so if there's a delta in y, then ty plus equals math.copy sign 1 dy. All right, I think we've got if this works, we've got our movement set. The last thing we need to do is track visited. We'll do visited equals, and we'll make a set. That's the notation to make a set. And we'll start with 0, 0 in that set because we start there. Now, after we move t, we don't need to do it only if we move the tail. Do we need to update visited? So we'll do visited.add, and then we can say tx comma ty. And then, probably should have called this part 1 because I'm guessing the visit is going to change, but we'll say part 1 equals when visited. I could have just put that in, but Python day 9 text. Oh, we got an answer, 6181, which I give it a try. All right, and we got it. Sweet. All right, we're continuing to part 2. So the rope snaps. Suddenly the river's getting a lot closer, blah, blah, blah. Let's see. Rather than 2 knots, you must simulate a rope consisting of 10 knots. So there's almost a 5-minute stretch here of me reading the puzzle, not explaining it well, mumbling and thinking. I type a couple things into VS Code and then I delete them. It's not interesting. So I'm going to shrink all that down real short and replace it with this. The description of what's going on in part 2 is that where in the previous part I had 1 knot and it followed the head. Now I've got 10 knots, the head and 9 tails, or 9 additional knots. And the head moves the same as before, but the tails, now the first tail follows the head the same way it did before. The second tail follows the first tail. So when the head moves one spot, nothing moves. When the head moves again, the first tail moves, and the second one's still 1 spot away, so it stays. And you can see I have to basically track each tail in relation to the previous one to see if it needs to move, using the same rules I used in part 1. So what I'm going to do is create I went on this long speech about how I'm using hx, hy instead of a vector. I'm gonna undo all that. I'm gonna go through and I'm gonna make first a two long vector, and then I'll be able to but in a way that scales so that later I can just change a number from 2 to 10 and get the same answer. So let's dive back in. So what we're going to do is first we're going to try to convert this to, we're going to convert our existing solution into, rather than using, because basically I could go through and say, T1x, T2x, T3x, but now after all the speech I just gave in the last second about needing not using vectors, we're going to have to use or a list here. So so let's comment this out, and we're going to say not equals 0, 0, because that's where all our knots start, times 2. Because we're gonna try to solve the two-dimensional case first and make sure or the two knot case first. Visited is still going to be equal to that. That's fine. Now let's see. Before we move here, so now this line is going to have to change. Those don't exist anymore. So we're going to say first the head is always going to be not 0. So we'll say not 0 equals. Now we need to update this. So we'll have not 0, 0 plus m of 0, comma, not 0, 1 plus m of 1. So we've now moved the head. Now we need to move each tail. So we'll say update tails. We can say for I in range, let's see, I'm going to go from 1 to len of knots. So right now, this is only going to happen once, because we're going to start at 1, and then when we get to 2, that's len of knots, so we'll stop. But I'm kind of trying to make it a generic case here, so we can push this in. And now in this loop, let's see, we no longer are going to have, our dx comma dy is going to be equal to knots of, so this would be the one in front of it. So I minus 1 of 0 for x minus knots of I of 0. So now we've got, that'll be our dx. We'll do dy on a separate row just to make it clean. It's actually going to be pretty, the way this one is going to be dy will be 1, like that. So now we've got our dx dy. And now let's see, so if absolute value of dx is greater, so that's kind of the same. And then we just need to change, instead of here being tx, this is going to be, let's comment this out and do it this way. We'll do knots sub I plus equals math.copy sign 1 comma dx. This one is no longer ty, but it'll be knots sub I plus equals math.copy sign 1.dy. And now we're going to add, comment that out, and we'll do visited.add knots. Oh, no, we don't do this. So we're only checking the last tail. So after all this is over, we'll do visited.add knots minus 1, the last knot. All right, so I think if this worked, we've now updated this in a way that we can make it work. So we haven't solved part 2 at all, but we've resolved part 1 in a more scalable way. And we've not totally done that. Okay, only can concatenate. Let's see what's going on here. Let's do this. We'll go minus m pdb. Add the Python debugger, and now when it crashes, we'll get a thing. So okay, we're getting our can only concatenate a float. Let's see. So what is dy? -2. Okay. Knots. Okay. Oh, I see. Because it's not sub I plus equals. It's going to be not. Okay. We can't have. This is not going to be not sub I because that's just the not itself. That's the whole thing. We need not sub. So really what we're going to need is we're going to really have to say new x equals not sub I sub 0 plus that. And we'll say new y equals that. And then we'll say not sub I equals new x new y, like that. So effectively what we have to do here is, because we can't, we're storing these all as tuples, and the tuples aren't mutable. You can't change them in a tuple, so we can only replace the whole tuple itself. So we'll just get the new values and put them in. Oh, but this is, that's not going to work either, because now new x or new y might not exist. So that's, ooh, I don't like that at all. Let's see. So we need else's? I guess we can say new x comma new y equals not sub I 0 comma not sub I. I don't like this, but we're gonna go with it for now because I don't see a better way. So we're gonna set new x and new y to be the originals, and then we're gonna change them if necessary, and then we're gonna update nots. Let's try that. Oops. Quit. Only concatenate tuple. Can only concatenate. Let's try it with PDB again. So let's see. Oh, because I need, this needs to be a 1. That's just an easy mistake. Run it again. All right, 6181. We've done it. So we spent all that time just to resolve part 1, but now in a scalable way. So the last thing we should do then is take, I wonder if we should take, I probably could have just created a second knots thing and handle it in this loop separately and left the original working. I wonder if that's worth, let's see. So if I take this and make this 10. Yeah, okay, I don't, that seems too messy. Let's go. Let's grab all of this. So we've got, so part of me says we make this a function and then we can call it with a, with this number right here. Yeah, let's do that. That'll be the best. So we can come up here. Let's grab all of this. Starting with right to here. And we'll say def process moves. We need the lines. We need the len, or I guess it's more num knots. Paste this in. Let's see what we got here. So how are we gonna make this a function? First, we're gonna need to indent all of this. Okay, so now this 2 is going to be num knots. We are going to then do all this stuff. We're going to get visited. And then the last thing we need to do at the very end is return the length of the knots. Return len. So now down here, we should be able to say part 1 equals process moves lines 2. Now we've resolved part 1 again. Let's see if it works, and it does. Okay, so now if this all works, we can say part 2 equals process moves lines 10. This is the real shot. Let's see what happens. Fewer spots. That seems so unlikely to me. Well, no, let's say I take that back. It doesn't necessarily seem unlikely because the last rope is not going to be whipping around nearly as much. 2386. Let's give it a try and see what happens. If this works, we'll be very happy. We did it. Awesome. So I know this was not the most coherent video. I suspect I'm going to do a little bit of like skipping through long segments of me staring at this, trying to figure out what's going on. But I think actually, hopefully that was not too hard to follow. Actually, the whole idea basically just being, it was kind of neat to see how we started with just two things, and we had to like go back and generalize that to be, okay, we're going to treat it as a list of unknown length and handle it there. So thanks for hanging out with me today. I will talk to you tomorrow.